For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination, and they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system, but this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 571501 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours, but that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler-186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler-186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it. But it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle in some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP890-9b and LP890-9c. Buckle up because we're heading to LP890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but is packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculoos telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP890-9b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP890-9c. This one was discovered by the Speculoos telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now, this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias, has found 2 Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these 2 planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet just like Earth, and if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP 890-9c. That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great! Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures and pressure and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere. In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact, if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our Sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called Pillars of Creation, an active star-forming region. Look, how cool is that?
As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So, hold on tight. The future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk Planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the Planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called superjupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery, and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP-103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next?
The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmers market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and tried to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the eighth and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions.
Tired of waiting for colonization? Does the Earth seem way too boring with all its problems and mosquitoes? Well, have no fear. It's time to take matters into your own hands and build your own planet. But before you start reaching for the cosmic glue and glitter, there are a few things you'll need to consider. Let's start our ultimate DIY project. First of all, we need to choose a location. Every planet has to orbit a star, right? In a cosmic buffet, every star has its own unique flavor. To keep things organized, astronomers use the so-called stellar classification system. The massive stars are the divas of the cosmos. They're huge, bright, and are always stealing the spotlight. But it's not all sunshine and rainbows. They have a short lifespan, burning out super fast, like a candle. They also have huge gravity, so be careful that your planet doesn't get sucked in. The dwarf stars, on the other hand, may be small, but they make up for it with their stamina. They can burn for trillions of years, which means that their planets have plenty of time to develop life. Super hot stars are blue or white ones, while the cold stars are usually red or orange. Yeah, seems like it should be the other way around, but we're not the ones making the rules. So what do we choose? Well, the planets around the blue and white stars could be scorched and fried, like a crispy chicken nugget. On the other hand, with cool red stars, our planet may turn into an ice ball. If that's your preference, then sure. But you can always pick a nice middle ground, a yellow star like our sun, for example. Not too cold, not too hot, but just right. Now that you've picked the star, let's start building the planet. The heart of the planet is its core. The core creates a magnetic field, an invisible force that protects a planet from harsh cosmic rays and charged particles. If it weren't for this field, the planet would be fried by the star's radiation, like a well-done burger. But the magnetic field isn't always a force for good. On some planets, like Jupiter, it's so strong that it creates super intense radiation belts and some crazy weather. If you were hoping to use a compass to find your way around on such a planet, forget it. The magnetic field would have the needle spinning like a breakdancer on caffeine. So, if you pick a small light core, the planet will have less protection from solar radiation, like tanning without sunscreen. On the other hand, larger cores can generate more heat, which can lead to more volcanic activity and earthquakes. The best option is a medium-sized core made mostly of iron and nickel, enough to keep the bad things away, but not too strong to turn a planet into a cosmic hot potato. Once the heart is in place, we can move on to the next step. Planets are like onions. They have layers. Most planets have three main layers: the core, the crust, and the mantle. The core is the filling, as we've already discussed. The mantle is like a hot and gooey layer of caramel between the crust and the core. And the crust is like a thin layer of icing on a planetary cake, covering its surface. But not all planets are built the same way. Because of that, we have tons of options. First up, we have the gas giants, the big boys of the universe. In our solar system, it's Jupiter and Saturn. They don't have a crust at all. They're basically huge balls of gas, like hydrogen and helium, hence the name. Next, we have the ice giants, like Uranus and Neptune. They're like younger, cooler siblings of gas giants. These planets don't really have a solid surface, but it's not pure gas either. They're made mostly of water, ammonia, and methane ice. There are also ocean worlds, and no, they aren't made of pure water. They do have some kind of solid surface, but it's located so deep, and the ocean on their surface is so huge that it kinda does look like a giant water drop. Finally, we have terrestrial planets, like the Earth. They're made mostly of rock and metal. These planets have a surface to stand on and usually come with a cool mineral collection. And let's not forget about the dwarf planets, the small but mighty. Pluto is probably the most famous one, but there are others in our solar system: Eris, Ceres, Haumea, and so on. They're the scrappy underdogs of the planetary world, always trying to prove their worth, but never making it to full-fledged planets. Which type do you like the most? Gas giants are probably the coolest ones with their enormous sizes, crazy winds, and scary lightning. We also need to create an atmosphere. It's the outer layer of a planet that plays a huge role in its climate and weather. It's also the planet's ultimate protector. Did you know that 90 to 95% of meteors burn up in the Earth's atmosphere? Imagine what would happen if they didn't. Dense and hazy atmospheres, the ones you'll find on places like Venus, have thick layers of carbon dioxide and sulfuric acid. In other words, it's not a planet, but an oven. It's so hot that you could cook a pizza on its surface in no time and get cooked yourself. Next, we have thin and wispy atmospheres, like on Mars. The thin layer of carbon dioxide makes its surface pressure about 1% that of Earth's. On planets like these, you could fly like a superhero if you had a good enough jetpack. Then we have mixed atmospheres, like the one on Earth. The layers of nitrogen, oxygen, and other gases create the perfect conditions for life as we know it. It's also where we get to enjoy sunny days, rainbows, and of course, water. And last but not least, exotic atmospheres. You'll find them on planets like Neptune, where the layers of hydrogen, helium, and methane create a blue-colored world that looks like a giant marble. They're super weird and unusual, so just perfect for creative planet builders. Almost done. The final question is, would you like your planet to have life on it? In that case, there are some things you should consider. For example, it should be located in the habitable zone. This is the sweet spot around a star where conditions are just right for liquid water to exist on the surface. Make sure your planet isn't too close or too far from its star. And don't forget about the temperatures. For example, you'll want a good amount of oxygen for a planet to be nice and warm, but not too much that everything spontaneously combusts. Of course, we need some water, but not too much, and a stable climate. You don't want your planet to be going through extreme swings in temperature or moisture. That's a recipe for extinction, not evolution. Oh, and the orbit should be stable, so that there are no major astronomical events that could throw things off. As you can see, this type of planet is very picky. No wonder it's so hard to find extraterrestrial life. Anyway, now that we've finished messing around in the Planet Creation Editor, how do we even build it? Well, how about terraforming? It's when we deliberately alter a planet's atmosphere, temperature, and other conditions to make it habitable for humans and other Earth-based life forms. For example, we could release greenhouse gases on Mars to warm up the planet and create a thicker atmosphere. But this method is more like polishing a monstrosity that was given to you by a character randomizer. What about building from scratch? That's something straight out of sci-fi. But maybe in the future, we could do that, using large-scale 3D printing or nanotechnology. We could create the basic structure and then add all the necessary conditions for life to exist. Of course, all this is still purely theoretical. But while creating a planet artificially is still a long way off, there are many creative ideas and concepts being explored by scientists and sci-fi writers. Who knows what the future might hold for the possibility of creating new worlds?
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, Who knows what kind of strange creatures might be lurking in those underground seas? But don't worry. Even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.